Dr. Chuck the Science Schmuck. Synchronize. Shoo, I've been building a lot of musical instruments. And yes, and that goes there. I've been building a lot of musical instruments, and I've been testing primarily all of them with this here Kona amplifier, which is a small 15-watt guitar amplifier made by Kona, who is mostly famous for their, Hawaiian-style guitars, which I do not play because I am not Double D from Ed, Edd n Eddy. But the idea occurred to me, I need a new amplifier. Well, amplifiers are expensive. They're not really that expensive. I could buy an amplifier with money, but then what's the fun in that? So I figured, why don't I do something a little different? This is a speaker. It's a really big speaker I bought on Amazon for $30, so I figure, why don't I make my own guitar amp? That's totally something I'm qualified to do, right? Alright, so we have the speaker. You can't just connect a guitar to a speaker, because the guitar does produce an output. I want to burn that hole in. A guitar does produce an output frequency, but it's very, very, very tiny. The point of an amplifier is to take that very, very tiny frequency and turn it into a big frequency that can then drive big speaker. That's about a 30-watt speaker, so it would make a pretty powerful amp if I can get this to work in theory. I don't know if it's actually a good speaker or a bad speaker. I just know it's a big speaker. And big speakers need big power. So what am I going to power this with? The answer is this. It already even has a switch. Which does beg the question, what is this? And the answer is a very heavy donut. You can't see it, but this thing's like 10 to 15 pounds. It's made of metal and wire, which is also made of metal. It is a transformer, a circular toroidal transformer from Transtonic. I bought it surplus, so this thing has a secondary of 30 volts at 6 amps. A transformer is basically, well, here's the unfortunate part. I really like to use those little wall warts that I can plug into the wall. Pretty much always have one. 12 volts, nice. Except it's like at most an amp. When you 12 volts, that's like a 12 watts. So yeah, that probably could power a very tiny speaker. But it's not powerful enough to power a guitar amp, is it now? The problem is, whatever comes out of this twice tripped my breakers, and, well, that was because I put it in backward, and, it's very buzzy, and I don't know how to build a proper bridge rectifier circuit. So we'll have to see if I can actually get consistent DC out of this thing. Okay. I wonder what that's for. Well, people always ask me, you filthy schmuck, why aren't you an engineer? This is the reason I'm not an engineer. I have no idea what I'm doing. I don't know how electronics work. I especially cannot stand amplifiers. Why did I start doing this project? I don't know. They're basically voodoo. I don't know how they work. It's not like a transistor or anything digital. Analog is stupid and pointless, and it doesn't do the same thing. You build the same circuit 3 times, it's going to do a different thing every single time. Now, I know that's not technically true, but that's what happens. I don't know. It's supernatural is believing in stupid stuff that doesn't exist. Subnatural is realizing stupid stuff does exist. And amplifiers are subnatural. They do stuff that they're not supposed to do, but do it anyway. But this circuit basically works. I don't know how, because there's a lot of workarounds for things in it that shouldn't exist, but do exist. But I did test it like 10 minutes ago. Oh, I got a nice breeze. That's the nice thing about not being in a basement. You get a nice breeze if you open the window. Blowing past some old Winogradsky columns that didn't actually do what they're supposed to do, so it's going to be a smelly breeze. The point being, I should probably go over this individually, because there's 4 main pieces here, and none of them do what they're supposed to do. Firstly, that is the regulator. At the end of this, I will need to apply thermal grease, because there's no thermal grease on it right now. I put in a heatsink, because the original regulator I built exploded. because I tried to put 20 volts through it, and it didn't like that, and all the magic blue smoke came out, and now suddenly it didn't work, only for me to then realize I only had one of those regulator chips. And it does not like it when you put a different regulator chip in the system, so I had to take over every subsequent piece and rebuild it. I don't know why. Apparently, those two capacitors, you need them. I don't know why. Which, power supply-wise, that does work on the one I had before with the big toroid, but we'll get to why I can't use that thing eventually. Second portion is an audio amplifier, and it's plugged in, as you can see. I built it on this board, because circuit boards makes logical sense. The thing is, it's basically a very simple circuit for the LM386, except I can't find an LM386, so I used an LM30N8, which I don't know what that is or how it works. Turns out there is a resistor in there that needs to be there. It doesn't need to be there. That's the weird thing is I tried op amps. I could not get the gain I want. Who'da thunk it? I literally don't have thunk it because op amps have basically infinite gain depending on how you do them. But an amplifier is basically you put two negatives into its amplifier butt, and the variation between the two gets amplified into a big outgoing signal. The problem being, I quickly discovered that that output signal actually doesn't drive a transistor. At least it didn't when I was starting. It did later, but by then I had already built a very different circuit, which is this circuit, which was originally a triple Darlington. It is now a double Darlington because I needed like a PNP transistor and I only had NPN, and then it ended up being multiple transistors, and who knows how they're connected. And it turns out that I was actually using two transistors during the prototype stage because one said Monaco and the other said Malaysia. And it turns out Monaco worked and Malaysia didn't. And I was like, why doesn't the finished circuit work, but the prototype does? Different transistor. That works on a principle that I don't fully understand. I drew it. It works like that. I don't know what that means, because that's a transformer. Apparently all these white things that I found in a box, they're transformers. This circuit I built out of intuition, but I don't actually know how it works. Because that's the amplifier, so that produces a signal which comes out, and then I put it through a transformer, so it goes out into ground, and then that makes this work. So I think what's happening is that when the transformer is not doing anything, and there's no signal in it, it's just a coil, it's just a conductor. So negative to this, which is, I don't know how to draw a PNP, or an NPN. It's an NPN. So it needs a positive signal to activate. But when it's default, that's just a negative. So it's off. When you put current through it, it produces an AC field which causes momentary positive spikes to exist in parallel to the main power source, meaning that it produces slight positives. So it actually powers that transistor through the transformer. Like, literally, it does work. I promise it works. I don't know if that's what's happening, because it's momentarily turning this side into a battery in parallel rather than a conductor, because transformers are weird. I tried it with big transformers, it didn't work, but it works with these little isolation transformers, which is not what they're for, but also, I think, close to what they're for. And then comes the problem with the power system. So I tried it with that. That one actually did work, because it didn't put enough current to vaporize everything. Putting a computer power supply in backwards onto everything did vaporize several components. And then I was so annoyed in that it was a basically working circuit back then. But I did the calculations, and I did all the math, and I figured out that this transistor, which is just an ordinary regular transistor, can power the circuit at 12 volts. So using, my regular 12-volt supply connectors, which can handle up to 12 watts. Can't handle 60, but kind of the weird thing that I realized mathematically with, this is an 8-ohm speaker, right? So it has a consistent current. Even in a short circuit, it's still 8 ohms, which you really shouldn't short circuit it, but the power of a speaker is not defined by its current, because the current is consistent. In a short circuit, it'll always be the same amount of current if the voltage is. So E equals I times R. Ear is Ohm's law, which is also ver, but I find ear funnier. So 12 volts equals 8 ohms times R equals 12 divided by 8 is 1. It's I, not R. So 1.5. So 1.5 amps is, in short circuit, how much current this can have at 12 volts based on its inherent resistance, which times 12 is a maximum of 12 plus 6. That's a maximum of 18 watts. And they say, well, this is a 300 watt speaker. Because the voltage, so apparently in speakers, the actual wattage output is dependent on the voltage. Sort of, because the speaker doesn't consume a continuous wattage because it can't. That would just be, and then it's at maximum. It doesn't make sound. Sound is varying the amount of power flowing through the speaker to make it vibrate and make sound. So a 300 watt speaker does not use 300 watts continuously. Sort of. You can do a push-pull. That would probably use 300 watts continuously. That would be putting AC through it. So even if I had got this thing to run at 20 volts, 20 equals 8 times I this time. 20, that would be 20 divided by 8 is what? 2.5? So it's 2.5 amps. So 2.5 amps times 20 volts is 40.5, so 50 watts. So if I had gotten it to work at 20 volts, it would run at 50 watts. The problem is it kept coming out that it would just overdrive the speaker and you wouldn't get sound out of it. So I thought, okay, there's two ways to approach adding resistance to that. The most logical is what this knob theoretically does, is it controls the input to the transistor. That has a reason, in that it's hard to find high wattage resistors, like these little resistors. That one's not connected to anything. They're like a quarter watt. It's not going to stand up to a lot of wattage going through it. So the transistor, in theory, can handle up to 2 amps with a peak of 4, meaning that if I use the transistor as a resistor, somebody's screaming, if I use the transistor as a resistor and just control it to act as the stop gate, it can handle that. But then it occurred to me, well, yeah, you can do that, but that's still just reducing the amount of power flowing through the system. So I added a 20 ohm resistor anyway. Now, you're going to say, where did you find a 20 ohm 60 watt resistor? Because that's like a giant piece of ceramic pipe that costs $300. But those of you who are observant have seen how I did it already. That's a light bulb. A light bulb is really just a resistor made out of glass. That's just a 60 watt bug light I got at the grocery store. I checked the resistance on it. It's 19 ohms. Don't ask me to explain why a 60 watt light bulb only has 19 ohms in it, because I cannot do the math to figure out why that's a thing. And I fear they may have variable resistance due to their temperature. But this one is not acting at 120 volts. It's only 12 volts, so it's going to act at close to 19 ohms to assist in series with this. So that's just a big resistor that can handle more power than the whole system can take. Very cheap, too. It was $3.99 for 2. You may not be able to get them in the future, because I wouldn't try this with an LED light or a fluorescent light. It has to be a resistive light, which is an incandescent or halogen. I can get a halogen in the future if I really need to. Although I don't know if halogen will support this application as readily. So that's the summary of the circuit and everything that's in it. Now, it does run on this supply, which is split. So the amount flowing through all this is 5 volts. It stops being 5 volts at this transistor, which connects to 12 volts. That way this thing isn't powering all of the current to drive the speaker. It's straight from the source, so it can do the maximum of 1 amp. It won't because of the resistor, but it doesn't put this in danger of driving the speaker, which that can drive the speaker. It just can't drive it loud. So if I connect it, that's not good. There should have been a sound. Okay, so I've connected it to this base, which is sort of on a stand, so it's not easy to see. Weirdly enough, it sounds like bad. That's kind of expected. Weirdly enough, it has this primer switch. I don't know why that's needed, but sometimes the amplifier won't amplify until you hit it with a little jolt of positive, so I put on a switch. Okay, so I find the amplifier has a hard time dealing with low frequencies. See, it's not working. Prime. Yeah, this bass needs to be tuned. I will tune it before this is in its final construction. This is just a test, largely. I also have a guitar, so guitar frequencies might work a little better. I can do a half power chord. And then if you put too much through it, it drives, overdrives, and you have to reprime it. Tea instead of normal coffee. They're from the same plant in that both plants are green, therefore identical. Just like this amplifier sounds like an amplifier, and therefore is as good as any amplifier you can buy off the shelf. The problem being, this is a system of pieces of wood connected to various screws with circuits hot glued to them, which has a switch that I need to turn it on. So it works, but it's not done yet. In that I'd like to give this a rudimentary case, just so that I can say, that's the amp. But I wanted to cover before I blow it up again, because yesterday I had this fully working. And then I decided, I wonder what would happen if I plugged a computer power supply and then this fizzled, and that transistor, which is now a piece of wire, because why not? Why do I need a transistor when I can just use a piece of wire? But technically means that that linkage is unnecessary, but I'm not going to undo any linkage from this except to exactly redo it. So what needs to be done now? First of all, that needs to go on a heatsink. That needs to go on not a heatsink. That heatsink needs to be fixed and have thermal grease applied to all heatsinks. Then these need to be bonded into a frame. And I want to put on indicator lights. Yes, lots of indicator lights. That will be fun. That's totally a thing I can do. And behold, a thing! I've actually managed to do it. I built myself a guitar amp. Now, admittedly, it doesn't look very amp-ish. The main issue being that the speaker is held down by monofilament line to keep it from moving. In theory, it should be mounted in a hole, but I have no way to drill a hole. Thought of trying to drill a hole forever and ever and ever. If it's not immediately apparent, this thing is made of the wooden slats of a pallet that I found in the dumpster, which I cut and screwed with a variety of random screws I found, and glued and nailed together into a box. The front, because the wood was, even this is thin wood, but it was too thick to actually mount the things, like the jack, which is there. It's made of plexiglass that broke. That was from my, it was the original lid of my paludarium. That did not work. The paludarium worked excellent. It's still going, but the lid fractured. So that's why there's blue tape on it, because it's just cracked to bits. I already pointed out that this is the jack. It goes in the front. At which point there are several switches and indicator lights. Firstly, it has a plug, which I made myself. That is not cut off of anything. That is homemade. It's very short. I wanted to have something that you could, like put a cord in the back like a normal amp, but nope. Interestingly enough, you see, that's not the plug of your 12-volt power supply. No, because this connects to an outlet, which is inside the device that is then plugged into. I could conceivably plug a vacuum cleaner into the amp and it would run just fine. It does make an interesting, although probably not very perceptible, electrical sound when it's connected. Extension cord. Now, I did say I was going to add indicator lights, and I have. So, hope I don't shock myself. That light there, if you can see it, that one is the 120 volts applied light. This is the primer switch. Normal amps don't have that, but mine does. Volume control paperclip, which doesn't work. And this is the 12 volt supply line. So when that red LED is on, there are 12 volts. Press the primer switch. There should be a click. Now, first is a base. I originally tested it with the base because it was nearest. Okay. Okay, so the weird thing is it works, but only for like half the notes. That's kind of a funny sound. It's weird because you kind of have to hit it really hard to get it to actually sound consistent, and I don't want to hit it too hard because it's almost 10 o'clock at night and there's people sleeping on the other side of that wall. You can probably tell I was never really a good musical player. So it works okay with bass. Let's try it with guitar. Yes, I have a fancy... Ooh, don't know what that was. Didn't blow out the primer, though. I'm even less of a guitarist than I am a bass player. Yeah, short answer is I can't actually play the guitar, which, why does my finger hurt? Hopefully I didn't touch something electric in there. The backside is entirely open, and the circuit is just hot glued in, so it's very stable. The light bulb is just rattling around in there, so it probably wouldn't... Burning acrylic, that's how you drill the holes in acrylic, because it just shatters if you try to drill it with a drill. Very smelly. But, let me just unplug this. Despite all the pitfalls and the difficulty in building this system, I would like to officially declare that this device is probably my greatest success ever. And looking at it, that is certainly saying something. So now I can practice. I mean, I have actual amps, but now I have an amp of my own construction, which I did show the schematics of this amp to Jungle Jim, and apparently I did it very wrong. So similar to what my drill circuit and multivibrator were, this will probably become a revisited project in like 6 or 7 years where I go back through the circuit and can't figure out what in the world I did and add an actual audio amplifier in the way that you're supposed to. But It makes sound when connected to instrument, and the sound, as terrible as it is sound. I therefore declare that the experiment and the science behind it must also, too, be sound. So, I made a guitar amp out of this $30 Amazon speaker and a bunch of parts that I found. Excellent. End.